Okay, for question 12, a student has a weight of 655 Newton. While riding a roller coaster, it seems to weigh 1960 at the bottom of a dip that has a radius of 80 meter. So the first thing, if you get this kind of question, you have to draw the diagram. So the diagram should look something similar to that. And they want to find centripetal force, that will be your FC. And then the speed of the student at this point, that will be your V. Okay. R is equals to 18 meter. That would be right from that center to there. It's 18. So R equals to 18 meter. And has a weight of 655. That will be your weight. W 655 Newton. And 1960 Newton. That one is apparent weight. Okay, so you can imagine if you are standing or you are sitting on the reading scale, that would be the reading of your N. Right, so that one is your N. Apparent weight. And if I identify all the forces on this, let's say this particular person, you have a weight downwards, and then since this person is sitting on the chair, you expect to have a N. So if I redraw the free body diagram, it will look something like this: weight downwards and upwards, and centripetal acceleration will be towards the center, which is upward. Okay, now for question A, summation of FC, you can straight away find the FC because they give you the values for N and W. So it should be the one that is the same direction with the AC minus the opposite direction. So it will be N minus weight. So it will be 1960 minus weight 655. Should get 1305. And the unit will be in Newton. Okay, B, the speed of the student at this point. Summation of FC equals to MAC. Okay, so this one is 1305. MAC is equals to MV squared over R. Okay, you do have the R, but you don't have the M yet. So you can find the M, or you can substitute inside there from the weight. So you know that since weight is equals to mg, so m is equals to weight divided by g. Okay, so 1305 is equals to weight divided by g r v square. So they want to find the v. So v here is equals to 1305 times the 9.81 times 18 divided by the weight, which is equals to 655, and take the square root of everything. 1305 times 9.81 times 18, 655, take the square root, 18.76 ms minus 1. Okay. Okay, for question 13, says that 200 gram object is whirled along in a vertical circle whose diameter is 1 meter. As shown in figure 5.1, if the time for one revolution is 0.9, what is the tension in the string? Point A, B, and C. Okay, so the mass is equals to 200, 0.2 kilogram. Diameter is 1 meter, so R is equals to 0.5 meter. Time for one revolution is basically the period. What is the tension in the string at point A? Okay, so if you want to do at point A, first of all, you have to draw the free body diagram. At this particular point, you have weight downwards, tension downwards, and then AC also downwards. So the free body diagram will look something like this: weight, tension, and AC in that direction. Okay, so the question want to find the tension. So if you write down the equation, summation of FC equals to mv squared over r. Oh, this one is ma first, right? And then this one is mv squared over r. And FC is basically T plus weight. So all the forces that is in same direction with the AC will be positive, and the opposite direction would be negative. So in this case, it's T plus W. So you don't have the values for V, but you do have values for omega. Sorry, you have values for T that you can find the omega. Omega is simply 2 pi over T. So your omega should be equals to 2 pi divided by 0 0.9, 6.98 radian per second. Okay, so you can change this formula in terms of omega, or you can find V first inside here. So V is equals to R omega. I want to keep that particular formula, so I change to V instead. R is equals to 0 0.5 multiply with 6.98. So your V is 0.5 times 6.98, 3.49. Okay, so I substitute everything inside here. So your tension is basically mass. You can factorize the M if you want to. 0.2 V square is 3.49 square divided by R is equals to 0 0.5 minus with the weight, which is equals to mg. So it will be 0.2 times 9.81. So here I got 2.91. The unit will be in Newton. Okay, that one is 4.8. At point B, which is down there, so the free body diagram will have a weight downwards, tension upwards, AC always towards the center of the circle. So if I redraw, will be T upwards, weight downwards, and AC upwards. Okay. So again, you can use summation of FC equals to MAC. All the forces that is in AC direction will be positive. T opposite is negative minus weight equals to mv squared over R. Okay, again, you already have the values for V. So weight to the other side becomes mg. V just now I got 3.549, so mass is equals to 0.2. V is equals to 3.49 square divided by 0.5, 0.5, and then plus mg 0.2 times 9.81. Okay, I think A and B is pretty straightforward. So I got 6.83. Okay, if you compare T when it is at the top and when it is at the bottom is actually at the maximum tension, and at the top here is actually at the minimum tension. It makes sense. You can try to do it by yourself, and you can feel that the tension actually minimum at the top, maximum at the bottom. And then the last one, C. Okay, so for C, the free body diagram will look something like this. You have weight pointing downwards, attention towards the center, and most importantly, your AC is towards the center as well. Okay, so you look something like that. Okay, and the angle, okay, this is the angle 60 degrees, so that angle represent over there. Okay, because this one is basically a zigzag angle, so 60 degree is over there. Okay, now I just want to redraw the free body diagram. Tension in that direction, weight downwards, and the angle there, if I'm not mistaken, is 60 degrees. Yes, 60 degrees over here. And then you still have the AC, which is in that direction. Okay, so like I told you before in previous chapter, in force punya chapter, you always want to put your acceleration in one of the axis. So maybe you can assume that this is your x axis, and this will be your y axis. So if you do that, okay, you can see that the weight is not on any of the axis, not on the x or y axis, so you have to resolve weight. Okay, and if you resolve weight, you will get wx in that, sorry, this is wy, because this one is y axis, and this would be your wx, and the angle there represent this angle, 60 degrees. Okay, because this is the line and this is the line, so it would be this angle together. Okay, now you want to write down the equation. If I write down the summation of FC, which is in this component, the forces that are in this component is tension and Wx. So same direction with the AC would be tension minus Wx equals to mv squared over r. Okay, you can write down the y component as well, so that one will be equals to 0 if you want to. Okay, but I just want to focus on this part because the question want to find the tension. So tension here, you should get mv squared over r. So mass is 0.2, v squared is 3.49 square divided by 0.5, and then plus with wx. Wx is mass times g, and then you have to multiply with cos 60 because that one is if you want to go from w to wx, you have to go through the angle, so that will be cos 60. Okay, remember, because you are entering 60 in degrees, so your calculator should be in degree as well. So here I got is 5.85 Newton.